shall introduce to you some fabrics which are named after certain finishes. Today, there are finishes which are called mechanical finishes, and examples of mechanical finishes are sand washing, sanding, brushing, then peach finish. A fabric is produced and then it is passed through a roller containing fine wire points. So the fibers are pulled out from the fabric and the structure is not at all seen, whether it is a plain weave or a twill weave, it is not possible. We get all the fibers which are produced by removing from the yarns. Such finishes are called peach finish, and peach finishing is practiced for knitted fabrics, for woven fabrics. It is also called brushing treatment. Now, there are a lot of changes which occur in the fabric after it has been subjected to a peach finish. The absorbency improves, the drape improves, and handle improves also, the feel. For example, a cotton fabric which is brushed on both the sides, it is called flannel. Flannel is very soft like a wool, and it is having good handle. Then flannelette. This also has got a good handle, and it looks as if it is a wool fabric and not a cotton fabric. So, we have some fabrics which are named on the virtue of the fact that they have been given certain finishes, peach finishes and other things, and the peach finish also results in less friction. See, in the case of wool, there is a finishing called milling, which is given and which takes advantage of the presence of scales on the fabric. See, wool has got scales which are something like shingles on a roof of a house, and it exhibits two types of friction, against the scale and within the scale. Against the scale, that is tip to root, is greater than root to tip. And when wool fibers are agitated in soap solution, they are converted to a material called felt. So this felting is given to the wool fabric, which is also called milling. So in the same way, a cotton fabric is given this peach finish in order to convert to a very soft substance so that it can be used for various applications. There is a term called sueded. That is something like leather-like finish is given to the material, and the calendering process. We have already talked about the calendering process in the case of the non-woven fabrics. Particularly a needle punch non-woven fabric, when it is given a calendering finish. A calendering is a mechanical finish. It is something like ironing. We put the material on a table and then press it with an iron box. Here it passes through two rollers which are heated up, and so that the material is compressed and it is given a consolidated finish. The fabric looks very compact following this calendering treatment. I am going to just tell you the fabrics which are defined by their finishes, and the example is napping, flannel. Flannel is generally a twill structure used for flannel shirts. Historically, this was a wool fabric, so it is heavier than a flannelette. Today's fashion demands include lighter weights in most fabrics. It is used in shirting and pajamas. The yarn used is a cotton yarn, which is a spun one. Flannelette. Flannelette is a lighter weight plain weave cotton-like fabric often used for pajamas and infant wear. The yarn used is 100% cotton, which is a spun yarn, and it is used in pajamas. Flannel and flannelettes have certain similarities. Similarities are those where napping is a mechanical finish that involves using a wire brush on the fabric, creating a very soft fuzzy surface with increased warmth. Napping is used in many other fabrics as well. Most of the pile fabrics are napped, including velvet, velveteen and corduroy, as well as fleece, knit, velvet, sweatshirt, fleece and velour. Differences lie in the fact that flannel is usually constructed of a twill weave and made of wool or cotton. It is often heavier than flannelette and is a warm fabric. Flannelette is a lighter weight plain weave fabric. Flannelette is often napped on both sides. Today, flannelette is more difficult to find as the knit fleeces have mostly replaced it. Emerizing, then sueding. Sueded interlock. This is a knit interlock fabric with an emerized finish, and it is one of the many imitation suits on the market today. It is used in shirting, jackets and bags. It is made out of 100% polyester filament, and the finishes applied are sueded and emerized. The other fabric is moleskin. Moleskin is used back satin, which means that it feels like suede on one side and looks like satin on the other side. It is used in shirting, jackets and pants. Peachskin. Peachskin has been emerized enough to give this fabric an extremely soft hand, but the process does not continue far enough to feel like suede. Peachskin is made in a rib weave, very much like a tissue fail. It is used in blouses and dresses. Interlock, moleskin and peachskin have a lot of similarities. These fabrics have been sanded with emery paper, emerized to make a softer, more suede-like surface. They are less fuss or hairy than fabrics that have been napped. Moiré fabric, a ribbed or corded fabric that has been subjected to heat and heavy pressure by rollers after weaving so as to present a rippled appearance. The effect arises from differences in reflection of the flattened and the unaffected parts. This type of fabric is also correctly described as watered. Moiré fault. It is an undesirable shaded effect produced when the weave pattern of one layer of fabric is impressed onto an adjacent layer of fabric, usually under the influence of heat and pressure during processing, example beam dyeing. And moirette, a plain woven cotton fabric with a predominance of warp or weft, creating lines across or down the fabric respectively. The finish is the same as for moirines. Moiré Taffeta. This comes under a specialized calendering fabric. Taffeta is a weave which is made of filament yarns. Moiré is a recognizable finish that involves applying a wood grain pattern to a rib weave with heat and pressure. The pattern was originally called watered silk. This is a taffeta fabric with a moiré finish. Then embossed interlock. Embossing means to use heat and pressure to add dimension to a fabric. This fabric is a three-dimensional interlock knit that has a design pressed onto it. It is made out of polyester and rubber, both in filament form, and embossing is the finish that is applied to it. It is used as jackets, dresses and evening wear. Pleated hex net. This fabric was heat set to create permanent pleats. Polyester is the filament that is used, and it is used in lingerie, evening wear, dresses. These fabrics have been calendered, which means that they have been treated with heat and specialized rollers to achieve their surface texture. Yoryu, this is used in lingerie and evening wear. Yoryu is a chiffon fabric that uses heat or a resin finish to crush or crinkle the fabric. This is simply a different type of pleating. It is used in lingerie and evening wear. Plissé, it is produced traditionally by a plain weave which is embossed or printed with a caustic soda, causing the printed areas to shrink and the other areas to pucker or buckle. Plissé can also be created by selectively placing spandex in the fabric, causing puckering. And it uses a spun yarn and the finishes are embossing. It is used in shirting, pajamas and blouses. Pleated, hex net, Yoryu and Plissé have certain similarities. Each of these fabrics has a three-dimensional surface. Heat is all that is required if the fabric is thermoplastic. If not, resins or a caustic soda are applied to make the changes permanent. Fulled jersey knitting Melton. Fulling is a process of taking fabric that has been woven or knitted and then applying heat, moisture and agitation. In effect, the fabric is felted, but it is felted fabric with a grain. Fulling effectively increases the density, count and weight of the fabric. This makes a sweater very warm and snuggly. It is used in coats, blankets and sweaters. Resin finishing improves the wash and wear properties of the fabric. Resin finishing is done mainly to improve the properties of cotton component of the blend. Polyester component does not require any finishing. Resins also impart dimensional stability to cotton component and a degree of pilling resistance to the fabric. One of the disadvantages of resin finishing is that it imparts certain hydrophobicity to the cotton component in the blend. Due to this, the moisture regain of the blend will decrease and the static charge will go up. Thus, the purpose of blending polyester with cotton to get certain desirable properties such as increase in comfort during wear due to increased absorbency and decreased static buildup will be defeated by resin finishing. These factors are to be taken into consideration while resin finishing polyester cotton blends. Resin finishing also improves the durable press and crease resistant properties of the blended fabric. This garment processing. Garment is produced after the fabric formation. The fabrics are cut and then the seams are put and the shirts, the dress materials and suitings, they are produced. And in some cases, the garments are given washes before they are marketed. So let us have a look at these various types of garment processing. This is done with a view to enhancing the aesthetic value of the garments and it gives value addition to the garment. Garments are washed in horizontal or vertical type of drum washers. The goods are loaded only around 30 to 40% of the machine capacity to get good washing effect. The wash effect largely depends on speed of rotation, drum diameter, material to liquor ratio and amount of garments loaded apart from the amount of chemicals used for different types of washes. Garment washing. There are different types of garment washing to meet the requirement of the buyer. Some of the common washes for non-denim garments are listed below. Softener wash, enzyme stone wash, pigment wash, detergent wash. For denim garments, the types of washes are D-size, softener wash, enzyme stone wash, enzyme stone bleach softener wash, enzyme stone bleach tint softener wash, dry process on garment and then any of the above washes, special washes like permanganate stone wash. Non-denim washes, softener wash. The garments are treated with cationic softener at pH 5.5 to 6 for 10 to 15 minutes or double softener, a cationic softener and a silicone softener depending on the hand feel required. The MLR is generally kept at 1:5 or 1:6. The treatment may be done at room temperature or 40 to 50 degrees centigrade. The treatment condition depends on the hand feel requirement of the garment. Enzyme wash. Enzyme treatment is applied to give a washed out look and a good hand feel. There are two types of enzymes, neutral enzyme and acid enzyme. Neutral enzyme works at pH 6.5 to 7 at a temperature of 55 degrees centigrade and give the garment an abraded look. Acid enzyme gives a biopolishing effect, remove pilling and imparts a good hand feel to the garment. This enzyme works at pH 4.5 to 5.5 and at a temperature of 50 degrees centigrade. The amount of enzyme varies from 0.5% to 2% based on the washdown effect required. Finally, a softener treatment is given. Enzyme stone wash. This is more severe wash compared to enzyme wash. The pumice stones give additional beating to the garments, giving a more washed out look. The amount of stones depends on the extent of abrasion required. It is generally in the range of 0.5 to 2% on the weight of garments. The enzyme quantity may be reduced. pH and temperature are to be maintained as per the enzyme wash. The garments are finally washed with softener. Pigment wash. In this wash, garments are treated with 1 to 2% of sodium carbonate and a detergent at 60 degrees centigrade for a specified time as per the requirement. This wash produces a good washdown effect, especially for pigment dyed printed garments. After neutralizing, softener treatment is given. Detergent wash. This is a simple wash involving treatment with a soaping agent at room temperature of or 60 degrees centigrade for 10 minutes and then finished with softener. Denim wash. There are different types of denim such as indigo dyed, and topped with sulfur dyes and vice versa. The different washes produced distinctly different effects depending on the type of denim. De-size softener wash. De-sizing is done to remove the sizes on the denim. The sizes like starch, carboxy, methyl cellulose, CMC, polyvinyl alcohol, PVA are applied during warping of the denim. The sizes are to be removed to make the garment pliable and receptive to further chemical treatment. This treatment is a must for all enzyme and enzyme stone washes. Desizing is done with a desizing enzyme at pH 6.5 to 7 at a temperature of 60 to 70 degrees centigrade for 10 to 20 minutes based on the amount of size on the garment. The garments are then rinsed with water and finished with softener. Enzyme wash. Enzyme wash is preceded by desizing and rinsing. The type of enzyme like neutral or acid depends on the effect required on the denim. The enzyme is deactivated by raising pH to 9 with soda ash or increasing the temperature of the bath and draining. After rinsing with water, the garments are finished with softener. Enzyme stone wash. This gives more abraded, washed look to the garment. The amount of enzyme and stone depends on the extent of abrasion required on the garment. After enzyme stone treatment, the goods are rinsed with water, stones removed from the garments and again thoroughly washed with water to remove stone particles adhering to garments and then finish with softener. Enzyme stone bleach wash. This wash is meant for heavily washed out denim. After enzyme stone wash, the goods are subjected to bleaching to further fade out the color. The selection of bleaching agent depends on the luster required on the garment. The bleaching agents generally used are sodium hypochlorite, calcium hypochlorite, hydrogen peroxide, sodium persulfate, potassium permanganate, glucose and enzymatic bleaching agent. Lacase based. The details of these bleaching agents are discussed separately. Enzyme stone bleach tint wash. Different tonal effects can be produced on heavily washed denim by tinting the denim after bleaching with direct pigment or reactive colors. Mostly direct dyes are used. With direct dyes, tinting is done at 60 degrees centigrade for 10 minutes with vacuum salt for exhaustion. The goods are rinsed with water and finished with softener. Dry process and washing. The reproduction of the localized used area that is formed in a garment during its use is achieved by initiating color wash down in specified part of a garment through mechanical, chemical and laser techniques. Mechanical process includes manual scraping, sand blasting, brushing, whiskering, etc. Chemical process includes hypochlorite and permanganate spraying. Laser technology produces definite contours on the garment by laser incision. After dry process, the garments are subjected to any of the washes as required. Special washes: permanganate wash, moon wash. This wash gives an uneven fading on the garment. The goods are generally pre-washed, enzyme washed or enzyme stone washed, rinsed and dried. Small size stones are soaked in 0.5% potassium permanganate solution, material to liquor ratio 1:1 for a minimum of 2 hours. The wet stones are then removed from the bath and put on a sieve to drain the permanganate liquor completely. The washing machine is run without load for a few minutes to drain any trace of water. Waste cloth is then loaded into the machine and run for 5 minutes to wipe out water completely. Then wet permanganate stone is put into the machine and run along with waste cloth for 3 to 5 minutes to remove excess water from the stones. Waste cloth is then removed from the machine and the pre-washed and dried garments are put into the machine. Garment to permanganate stone ratio may be done for a specified time. The machine is then opened and the garments are checked for the desired effect. If the effect is not sufficient, the garments are rescattered manually and again run for a given time till the desired uneven faded effect is obtained. The garments are then given a water wash and taken out from the machine, stones removed and the garments reintroduced into the machine and treated with sodium bisulfite at 40 degrees centigrade to neutralize the permanganate. The goods are then rinsed, acetic acid washed and soaped, then finished with softener. This wash is done on denim garments and also on non-denim garments dyed with permanganate dischargeable colors. Soil release finish, oil and water repellent. The garments are treated with oil and water repellent chemicals like stain guard, Resin Yoryu 3 to 4% on weight of garment at a pH of 4 to 4.5 and MLR 1:8 for 10 to 15 minutes at room temperature, hydro-extracted, tumble-dried, pressed and cured at 150 to 160 degrees centigrade for 10 minutes. The treated garments exhibit excellent oil-water repellency which is durable to several domestic washes. Wrinkle-free finish. The garments are treated with a mixture of the following chemicals at MLR 1:1 by dipping or spraying in a non-perforated drum washer fitted with nozzles at normal rotation for 20 to 30 minutes, hydro-extracted to 50 to 60% of moisture, tumble-dried to 10 to 15% residual moisture, steam pressed for 10 to 20 seconds at 160 degree centigrade, vacuumed for 5 seconds, and finally cured at 160 degree centigrade for 8 to 10 minutes. The recipe is as follows: DHDMAU resin 5 to 6%, magnesium chloride 1.5%, polyurethane emulsion 1.5%, silicone emulsion 1.5%, polyethylene emulsion 1.5%, water 89 to 88%, pH 5 to 5.5. The garments have good wrinkle resistance and crease retention properties which will withstand at least 20 domestic washes. There are other washes like fragrance wash, finishing with aloe vera for skin protection, antimicrobial wash, moisture management, finishes, etc. Details of products used in finishing. Pumice stone. These stones are produced from volcanic eruptions. They are porous stones with uneven edges. These stones are available in Greece, Turkey. The composition of the stone is as follows: silicon dioxide 55 to 75%, aluminum oxide 10 to 16%, sodium oxide 3 to 6%. Other components include potassium oxide, calcium oxide, and iron oxide. Enzymes. Enzymes are produced by microorganisms such as bacteria, fungi, wheat, algae, or viruses. They are high molecular weight proteins. Enzymes accelerate chemical reactions without being consumed, hence they act as catalysts. During washing, enzymes form a complex with substrate, cellulose, and the reaction takes place. When the reaction is terminated, the enzyme is available for a further cycle. There are different types of enzymes as detailed below. Alpha amylases used for desizing of textiles containing starch, cellulases used for modifying the surface of cellulosic fibers, In this, neutral and acid enzymes are available. Cellulase is temporarily bound to the cellulose through a reactive group and detaches the cellulose at its 1,4 beta glucoside compound. Afterwards, it is available for further hydrolysis reactions. Neutral enzyme produces abrasion and color loss on the garments. Acid cellulases are of two types, one producing abrasion, biopolishing with color loss, and the other only biopolishing, removing hairiness with minimum color loss. Proteases used for modifying wool surface to vary the handle. Catalases used for destroying residual peroxide on bleaching. Lacase used for bleaching of denim to give a grey cast. Bleaching agents. There are different types of bleaching agents, each giving a different cast to indigo denim. They destroy the indigo by oxidative or reductive reaction. Some of the bleaching agents and their working are outlined below. Sodium hypochlorite. This bleaches by oxidation. pH is the most critical for controlled bleaching of the garment without much loss in fabric strength. The most appropriate pH is 9 to 11.5. Soda ash is used to adjust the pH. Hypochlorite bleaching is generally done at room temperature. For faster and more color fading, temperature may be raised up to 60 degrees centigrade. The chlorine is very active during the first few minutes of the process. Once the chlorine is consumed, the decoloration stops. That is why chlorine bleaching should be run only for a short duration to avoid drop in pH. If the required fading is not achieved in the first run, the bleaching process can be repeated with fresh bath of sodium hypochlorite. Once bleaching is over, the goods are thoroughly washed and anti-clot treatment given using sodium bisulfite or sodium thiosulfate or hydrogen peroxide at room temperature or at 40 degrees centigrade for 5 to 10 minutes and finally water washed. Potassium permanganate. Permanganate bleaches by oxidation. It gets reduced to manganese dioxide during bleaching and the garment becomes orange-brown color. This brownish color disappears only on neutralization with sodium bisulfite or hydrogen peroxide at room temperature or oxalic acid at 70 degrees centigrade. This bleaching gives an yellowish cast to denim. Glucose. Glucose bleaches indigo by reduction. The bleaching is carried out at a highly alkaline pH and high temperature. Recommended bleaching recipe is given below. Glucose 8 to 10 grams per liter. Caustic soda lye 14 milliliter per liter. Temperature 90 degrees centigrade. Time 10 minutes. The bath has to be emptied after 10 minutes as the glucose loses its activity fast. Hence, if higher decoloration is required, the process has to be repeated with a fresh bath of glucose. Glucose bleaching gives a grayish cast too. We have got some standards for this ultraviolet protection also, which is considered to be very good, which is considered to be poor. And these nano finishes are used in a variety of applications. It is used in finishing, and the effect of this nano finish on crease recovery has been examined. The effect of nano finishes on water repellency has been examined. The effect of the nanoparticles on the efficiency also has been very well covered. So, the zinc nanoparticles, titanium or tin, copper have been produced and then studied on the textile materials for various types of textile materials like polyester, polyester cotton blend, then cotton, viscose, wool, etc. These effects have been studied. Now let us discuss something about these flame retardant finishes, which are very important today. Now there are some textile fibers which resist fire. All of you know that compared to cotton, wool has got a certain advantage. In fact, when a person is attacked by fire, he is asked to cover himself with a woolen garment, because wool has got a tendency to burn very slow, whereas cotton burns very fast. And some of the fibers like polyester, nylon melt. And special types of fibers have been developed in order to impart this flame retardancy, Kynol, Nomex, or the fibers which are available in the market. And special types of rayon have been developed by pyrolysis to offer this flame retardant effect. So, from the fiber side, and when fabrics are made, the fabrics are given various treatments. The very simplest way of conferring this flame retardant characteristic is to treat the fabric with common salt, sodium chloride, or alum. This is also used as a flame retarding agent, but then the effects are temporary. When they are washed, the effect of flame retardant effect is lost. So in order to have a permanent effect, special types of chemicals have been developed like THPH for applying onto the materials. This is a patent, and the tests which have been carried out using this THPH have clearly shown that there is a very good improvement in the flame retardant characteristics of the garments. In fact, some of you would have heard about the accidents which have occurred in the schools where many school children have perished due to the fire. So, use of these flame retardant fabrics in places where there is a possibility of this fire taking place will help a great deal in overcoming this problem. Now, as far as the tests are concerned for checking this flammability, we have a very simple test called horizontal flame test or vertical flame test. A burner is taken and the fabric is just kept above this flame. The time the fabric takes to catch fire is monitored, and if there is a delay in taking the fire, it is inferred that the fabric has got the flame retardant effect or otherwise. So horizontal flame tests and vertical flame tests are very simple tests to prove that the fabrics are endowed with this flame retardant effect. And there is a camphor test. The fabric is made in the form of a small sofa and a camphor is kept on that and lit. The time taken for the fabric to catch fire is monitored, and depending on the time, the flame retardant effect is being monitored. We have got instrumental methods of checking this flame retardant effect, and one very important, the mannequin test. The fabric is drawn on a mannequin and then it is allowed to catch fire. This simulates to some extent what is happening in our garment when we are in a fire accident. So these mannequin tests are being performed, and the other test that is carried out to prove that the flame retardant effect is present in the fabric is called the differential thermal analysis, or TGA as it is called, thermal gravimetric analysis. In this case, this is the weight loss, percentage weight loss and temperature. It is a well-known fact that when a material is subjected to a fire or a heat, after some time the weight loss occurs, and we monitor the weight loss as a function of time. Suppose the weight loss has occurred at a very high temperature, and so A is considered to be having a very good flame retardant characteristics when compared to B, because the loss in weight is much less when compared to A. So thermal gravimetric analysis technique is used for monitoring this weight loss as a function of, say, temperature. So as the temperature increases, the weight loss decreases. So in this case, at a particular temperature, the weight loss is much less in B. So B is having a higher value of flame retardant effect compared to A. Thermogravimetric analysis or thermal gravimetric analysis, TGA. This is a method of thermal analysis in which the mass of a sample is measured over time as the temperature changes. This measurement provides information about physical phenomena such as phase transitions, absorption and desorption, as well as chemical phenomena including chemi-isorptions, thermal decomposition, and solid gas reactions, example oxidation or reduction. The thermogravimetric analysis is conducted on an instrument referred to as a thermogravimetric analyzer. A thermogravimetric analyzer continuously measures mass while the temperature of a sample is changed over time. Mass, temperature and time in thermogravimetric analysis are considered base measurements, while many additional measures may be derived from these three base measurements. Applications of TGA include the thermal stability of a material. In a desired temperature range, if a species is thermally stable, there will be no observed mass change. Negligible mass loss corresponds to little or no scope in the TGA trace. TGA also gives the upper use temperature of a material. Beyond this temperature, the material will begin to degrade. The measurement of color in a material, whether it is a fiber, yarn or a fabric, is very important, because to dye the material we use a certain percentage of shade, and the customer requires a particular color for the material, a shirting or a uniform material, and if there is a variation in that, it is rejected. And earlier the matching was done by visual observations. A fabric which contained some color was dyed using trial and error method, and every time after the fabric has been dyed, it was compared with the supplier's material, and when the stage had come when it matches with that color, then he takes up it for the mass production. That takes a lot of time, and the human eye, all said and done, is also not accurate. The eye may have certain defects like color blindness or the difference between person to person, and that creates a lot of uncertainties in the color judgment. So in order to avoid that, we have today a computer color matching system. Now, when light falls on a material, depending on the stage of that, if it is a translucent material, all the light is absorbed. If it is an opaque, the light is not absorbed, it is reflected. And if it is intermediate between that, a certain portion of the light is absorbed and certain portion is scattered. So, a textile fabric, suppose it is an undyed fabric or a black dyed fabric, the reflectance of that will be quite different when light falls on that. So this is the basic theory on which this computer color matching system works. And a portion of light is absorbed and another portion of light is scattered. So based on this, there is a Kubelka-Monk system called K by S, where K refers to absorbency and S refers to scattering, and this K by S is given by 1 minus R the whole square divided by 2R, where R is the reflectance. And when R value is very high, then the value of K by S is very low. So when the reflectance, when the material is white, the reflectance is very low, and from the reflectance value one could calculate the K by S value. For example, the higher the value of R, lower the K by S value, and lower the value of R, the higher the K by S value. And K by S value gives an indication about the color strength or the color uptake. And another way of getting the color is to take the dyed material and to find out its optical density. So optical density measurements of the material before and after dyeing also is capable of giving an idea about the color strength. Now here, the color strength, if it is higher, it means that it is darkly dyed. Or suppose there is a material which is dyed with 1.1% shade, then 0.2%, etc., 2% shade, then K by S value will be increasing. Or the relation between the percentage shade and K by S value is something like this. So we could calibrate the percentage shade from the K by S measurements and then keep that for different dyes, which will serve as a ready reckoner. And suppose a sample is given by the person who wants the material to be dyed, or by a customer, and then it has been dyed, and both materials have been tested for K by S value, and it is found that there is no change in the K by S value at all. That means change is zero. It shows that whatever material that the customer has given has been executed completely, and there is no variation in the dye uptake. So that is the situation which is desirable in any dye house manufacturing unit. Unfortunately, due to various factors such as the type of the dye used, the concentration, the chemicals used, the time during which the dyeing is being carried out, the operator's skillfulness, so all these contribute to variation in the dye uptake. And to what extent we can tolerate this? So that is called by delta. So a manufacturer, a dye stuff, a dyeing unit owner says that we are capable of giving 0.5 delta. That means that the variability between the color strength supplied by or from the customer and what they have produced is not very much different. And if it is 2 and above and all that, that gives cause for concern. That means whatever that has been dyed has not conformed to the specifications of the customer. So in that way, a computer color matching system helps a great deal. And here, the method of determining this K by S is also somewhat different. Now when we use a spectrophotometer and then find out the relation between the wavelength and the reflectance value. This is the reflectance value R and wavelength. See, naturally we go from 400 to 700 nm, and perhaps we may get this type of a curve. So this is the maximum one. So the reflectance at which the maximum at a particular wavelength where the maximum occurs is also taken as a dioptic, because this corresponds with the maximum shade that has been obtained. And there is another way of computing K by S from the reflectance value, that 400 and 410, in increment of 10 it is taken up to 700, and all the K by S values are added. This is called incremental K by S value, which is far more reliable than the delta maximum or lambda max, because this takes into account all the wavelengths starting from 400 to 700. And we have got the color coordinates which are obtained. That is A, B, C, K by S value. And with the standard, the color coordinates are obtained. Sometimes they take that as a standard, or without standard also the color coordinates can be obtained. And how much greenish element is there, how much reddish element is there, it's all analyzed using these ABC values. And there is a relationship between the K by S value and also the whiteness value or the color coordinates. So color coordinates provide a fund of information about the details of the color. And as I said, that if the value of R is less, then it indicates a higher value of K by S. For example, there may be two values. This is having a lower value, this is having a higher value. So the fabrics which give rise to a lower value of reflectance have a higher K by S value, because here the R is taken in decimal. If it is 90%, 0.9, and R squared is 0.9 the whole squared, that is 0.1 divided by 0.8 or something like that. So the K by S value is computed like that. If the value is very low, 0.1, it becomes 0.9 and 0.1. So 9, K by S value is 9. So one can see how the reflectance value affects this K by S value. And another use of this computer color matching system is to find out the fastness properties. Apart from dyeing the fabric, what is most important is its fastness towards various agencies like light, fast washing fastness, perspiration fastness, rubbing fastness, and light and wash fastness are of utmost importance. The one simple test that is done to find out this wash fastness is that two white fabrics are taken and the dyed material is sandwiched between them and it is washed in soap water. After some time, the white fabrics is examined to see whether there is any stain deposited on it. If the color has been transferred onto the white material, it is a clear indication that the wash fastness is poor. And the use of these gray scales was pointed out in one of the lectures to find out the fastness properties. That is a subjective one, but using computer color matching system is an objective one. And what is done here is, before washing the K by S value is determined, after washing K by S value is determined, and if these two values are similar, it means that the fabric has got very good wash fastness properties. Similarly, light fastness properties. Light fastness is usually determined with a lamp which simulates the sun. So the sample is exposed to this lamp for a certain duration and then its K by S value is determined. The K by S value is determined before exposure to this lamp, and after exposure, if they are found to be the same, it is an indication that the fastness property to light is very good. Otherwise, it is entirely different. Similarly, perspiration fastness properties also can be determined. And another use of this computer color matching system is, I told you, to find out the recipe because no single color is used in the dyeing of a garment. It is a combination of colors to suit the customer's requirement. And to find out what dyes are to be used and in what proportion they are to be mixed, the computer color matching system gives a very good information which enables the dyer to use that shade for the dyeing of the fabric. Matching system also can be used to find out the quality of the dye that is used. What is found is some of the dyes which are supplied contain a lot of adulterants, and in some cases it is required to purify them. So that sort of a testing can be accomplished using these computer color matching systems. I would like to spend some time on this Kawabata evaluation system. For fabrics. This is used to find out the handle of fabrics. Handle of a fabric is something which is not definite. Now, silk, for example, we feel and say handle is very good. So, in relation to silk, if other fabrics are felt and then graded, it gives an idea about the handle of the other fabrics, no doubt. But then what we get is a subjective assessment of the handle. But in order to have an objective evaluation, it is necessary to do certain tests. When we feel a fabric for finding out this handle, we just rub it. So there is a frictional effect between the finger and the fabric. The fabric is a little compressed. The fabric is bent. The fabric is sheared, and the fabric is also stretched. So we have a combination of the tensile, bending, shear, friction, surface, roughness, and thickness of the fabric, which are considered indirectly. Now in Kawabata evaluation system, all these are measured instrumentally. So we measure bending, then shearing, then compression, then surface roughness, of course weight of the fabric and thickness. Now all these properties are measured for a fabric which are non-destructive, and from this first PHV is obtained, that is primary handle value, and then THV, total handle value. If the total handle value is something like 4.5, it means that the fabric has got excellent handle. Suppose it is 1, poor, 2, somewhat better, 3, good, 4 means very good, but 4.5 to 5 is excellent. So we get an objective measure of the handle of the fabrics from all these mechanical properties, and it enables us to classify the fabrics according to their handle. Handle is very important when fabrics are marketed. Certain people want a fabric to have very good handle, a suiting or a shirting. It has been found that of all the textile materials which have been tested for handle, silk outbeats all the other fabrics in terms of handle. It has got an excellent handle, and no doubt silk sarees give better drape also. So that is, drape is an aesthetic property, whereas this is a property which is very much required for feel. And the effect of various fibers on the handle of the fabrics using this Kawabata evaluation system has been studied. Effect of using different types of yarns, rotor yarns, ring yarns, compact yarns, and also the blends, the effect of blend composition. For example, polyester and cotton are blended in different proportions, 80-20, 67-33, 50-50, reverse blend, etc., then what is the effect of this blend composition on the handle of the fabric? And another important application of this Kawabata evaluation system is when the fabrics are subjected to certain treatments like low temperature plasma or nanoparticles, zinc nanox particles, and some of the resins, DHDM EU, dihydroxy dimethylol ethylene urea. So, and flame retardant chemicals also. Because apart from the fact that the fabric has got the resistance towards fire, its handle should not be impaired. If there is a harsh feel, then it may not be acceptable. So, we must ensure that the fabric has got two things. One is the ability to resist fire. Number two is, even with the treatment, the handle is not impaired. So, to determine the handle of the fabric of the treated material, the resin treated material, the Kawabata evaluation system is used. Even today, Kawabata evaluation system has been found to be very useful in many laboratories and in marketing and in the development of new types of fabrics also. Now, another system that has come out now is the fabric touch tester, developed by Hong Kong Polytechnic. This fabric touch tester includes thermal conductivity property in addition to all these properties. And thermal conductivity is the ability of the material to transport heat. The lower the value of thermal conductivity, the better the thermal insulation, because thermal insulation is given by m divided by lambda, where m is the thickness, lambda is the thermal conductivity. And the units are m squared k divided by w, where m squared is the thickness, k is the Kelvin, temperature, w is the watts, that is the heat transfer. So, the fabric touch tester is an advancement over this Kawabata evaluation system for determining all the properties of the fabrics, the uniform materials, the various types of garments which are being developed, the softness and the comfort. So, comfort, of course, Kawabata evaluation system also has got a unit for determining the thermal conductivity called Thermo Labo and an air permeability tester. But this touch tester combines all the measurements. Maybe it is an advancement compared to this Kawabata evaluation system, and some papers have been published in which the results obtained on this fabric touch tester have been examined. Now let us talk about some of the finishes which are applied to the fabrics. One is the silicone finish, and the silicone finish is applied to soften the fabric, and it also imparts these water repellent characteristics. They give better crease recovery property, better abrasion resistance, and also a soft feel. And for knitted fabrics, the silicone finishes are a must for improving their properties such as water repellency and this handle. And anti-crease finishing. Now, this finish is given to the woven fabric and not to the knitted fabric. Crease resistant finishes are very common during the last 60 years or so, and what changes occurred were that this formaldehyde was replaced by another compound, that is butane tetracarboxylic acid, and efforts to reduce formaldehyde in N-methylol cross-linking system for fabrics and garments have resulted in many changes in the formulations used for this finishing of cellulose containing fabrics. Formaldehyde release from fabrics has been a concern for many years as it causes dermatitis and respiratory problems even at parts per million ppm level. Eco standards prescribe limits of 75 ppm and 20 ppm free formaldehyde for close to skin and baby clothing respectively. Free formaldehyde is present in UF and reactant resins, urea formaldehyde, reactive softeners, fixers for pigment printing, and cationic dye fixing agents. To avoid formaldehyde release from finished goods, non-formaldehyde resins, softeners and fixing agents have been introduced in the market. Resins based on dimethyl dihydroxyethylene urea and polycarboxylic acid with low or no formaldehyde are being used for anti-crease finish. Example, natrium CRA of Supertex. Then another development which occurred in the polyester fabrics for improving their handle was this weight reduction. When polyester is treated with sodium hydroxide at 70 degrees centigrade with a 10% concentration for about half an hour or so, results in a weight loss. So the fabric become thin, and the properties of the fabric following this alkaline hydrolysis resembles that of silk. So taking advantage of this effect, many industries are giving these weight reduction treatments to 100% polyester fabrics. The weight reduction and consequently the feel are dependent on A. concentration of sodium hydroxide, B. temperature of treatment, C. time of treatment, material to liquor ratio, nature of fabric treated, spun filament or filament, and also the denier of the yarn used. Weight reduction can be done either by batch-wise process in jet dyeing machine or by continuous process, pat, steam, heat, wash. A guideline recipe for weight reduction of 80-20 polyester cotton shirting in jet dyeing machine is given 10 to 12 GPL sodium hydroxide grams per liter, 2 grams per liter weight reduction catalyst, and this material is treated at 120 degrees centigrade for 30 minutes, washed, hydrogen peroxide bleach followed by chloride bleach and washed. The weight reduction takes place is around 18 to 20%. For continuous process, around 30 grams per liter of sodium hydroxide plus 2 grams per liter of catalyst are used. However, the exact quantity of alkali required for a given finish has to be determined by trial and error. Generally, 8 to 12% weight loss on polyester gives a silk-like feel. When the material is tested for workability, it is found to be very good, and the drape also has been found to improve, and bending rigidity has reduced, the handle has improved. So in all respects, this weight reduction has been beneficial to improving the performance of these polyester fabrics. We shall spend some time in talking about this antibacterial finish. Antibacterial finishing agent based on halogenated phenoxy compound and isothiazolinone derivative has been introduced by Clariant India Limited under the brand name sanitized T90-Z4 liquid. It can be applied either by exhaust method or pad dry technique. General recipe is 10 to 20 grams per liter of sanitized T90-04 liquid, 1 to 2 GPL Sandosin NIN liquid wetting agent, pH is adjusted to 5 with Sirix 2 UDI liquid, pad dry at 120 degrees centigrade. It exhibits an anti-odorant effect, has excellent wash fastness properties, produces lasting hygienic freshness, and the finish is fast to dry cleaning, ironing and perspiration. It can be applied to all articles of apparel which are susceptible to problems of hygiene in normal daily use. Example, socks, sportswear, workwear, pillow, blanket, bed linen, etc. Then biofinish. Bioenzymes are being used to give different types of finishes on cellulose fabrics. A liquid cellulose preparation sold under the name Cellulose Soft L is used for enzymatic finishing of cellulosic fabrics. This is called biopolishing. Biopolishing improves the fabric quality by 1. Reducing fuzziness and pilling, 2. Improving fabric handle by making it soft and smooth, and 3. Enhancing gloss luster and color brightening. 0.5 to 2% OWF enzyme, depending on the finish required, is applied on the fabric in jet dyeing machines at 45 to 55 degrees centigrade at pH 4.5 to 5.5 for 60 minutes. The enzyme is deactivated by 1 gram per liter of anhydrous sodium carbonate at pH 9 to 10. A weight loss of 3 to 5% will usually give a satisfactory biopolishing effect. Bioenzymes are also used for garment finishing to give stone washed effect, particularly on denim. Then flame retardant finish. In most of the developed countries, flammable textiles have been banned by government regulations, and thus fire retardant chemicals and fibers have been developed to quite an advanced stage. In India, flame retardant finish is given only in cases where it is totally mandatory or in highly specialized end uses. In flame retardant finishes, either of the 3 following methods can be used. A. Application of a flame retardant finish to fiber, yarn or fabric. 2. Incorporation of a flame retardant additive during or immediately after the polymerization reaction to produce modified fibers. 3. Development of new flame retardant fibers. We have fibers like Kinol, Nomax, polybenzimidazole, which are all flame retardant fibers. And in some of the viscose rayons which are pyrolysis, they are also considered as flame retardant fibers. Chemicals which can be used as flame retardants are compounds containing phosphorus and nitrogen, phosphorus and halogen, or only halogen, as well as inorganic compounds based on antimony and other elements. Among the durable flame retardant chemicals, the one marketed by Ciba Geigy under the brand name Pyrovatex CP New has been found to be very effective. It is based on a dialkyl phosphonocarboxylic acid amide. A typical recipe on 100% cotton drill 16 into 10s, that is warp is 16, weft is 10s, 96 ends per inch, 48 picks per inch is Pyrovatex CP New 400 grams per liter, Fixer CCL 80 grams per liter, phosphoric acid 25 grams per liter, silicon softener 6 grams per liter, non-ionic wetting agent 2 grams per liter, pickup 65%, pad dry cure. Any unfixed Pyrovatex CP or acid from the catalyst is removed by alkaline washing of sodium carbonate 1 grams per liter. The finish is resistant to repeated washing at the boil, minimum 50 washes, and dry cleaning. The product has been successfully used in the workwear and drape segments. And some information about the effluent and the treatment that is given to clean or to handle it. Now, effluent is nothing but the waste that comes out of a dye house after bleaching, after dyeing, after wet processing, after finishing. So they contain lot of chemicals which are to be removed if that material is going to be used for agricultural purposes or for reprocessing or for drinking, as the case may be. And modern wet processing in modern effluent management includes recycling of less polluted streams and treatment of highly polluted dye effluent by latest technologies such as electrolysis, membrane separation technique, that is reverse osmosis, multi-stage evaporation, etc. Wet processing effluent is a complex in nature with all objectionable characteristics, highly colored and with high values of pH, TDS, total dissolved solids, BOD, biological oxygen demand, COD, chemical oxygen demand, etc.